Hi everybody, this video is to review Unit 6 for the Unit 6 Quest. I want to give a little shout out to my 5th period class who chose all the problems except 7 to go over on this sheet. So I hope you all get a good review from this, and let's get started. Now before we do these first 3 problems, we have to remember that arc cosine and arc sine have very limited ranges. The range for arc sine is negative pi over 2 to pi over 2. This is arc sine. And this is also very similar to the range for arc tangent. And then for arc cosine, the range is 0 to pi. So that means that all of our answers have to be between negative pi over 2 and pi over 2 for arc sine and arc tan, and between 0 and pi for arc cosine. So each of these examples will have one answer and one answer only. So the arc tangent of negative 1 is negative pi over 4. For arc cosine, remember we have to go into the second quadrant because this ratio is negative. So the family is pi over 6, and this will be a 5 pi over 6. And for this one over here, again, we're looking at arc cosine, so we're looking into the second quadrant to get the angle for this, and it's going to be 2 pi over 3. Now, number 9 is an example of a composition of trig functions. So we're looking at arc cosine of 1/2. So the arc cosine of 1/2 is pi over 3, and the sine of pi over 3 is root 3 over 2. Notice how with compositions of functions, if you start with a ratio, you finish with a ratio. Now for number 12. Number 12 is not an example of a special angle on the unit circle. So for that one, we're actually going to have to make a graph. So I'm going to go ahead and make a coordinate plane. And what I'm going to do is I'm going to notice here that I have a positive ratio. Since my ratio is positive, it means that my triangle goes into the first quadrant. Now remember, arc sine and arc cosine are only defined on 2 quadrants. Otherwise they're not functions anymore. So arc sine is defined up and down, positive, negative, and arc cosine is defined right and left, positive, negative. Well, since this is a positive ratio, it's going to go into the first quadrant no matter what. So the sine is 12 over 13, which means that my missing side is 5. So the tangent of the arc sine of 12/13 is 12 over 5. Now this next part is just sheer memorization. It's just observing what we did on the graphs the very first day of this unit. The domain of arc sine, remember this is the inverse of sine, is negative 1 to 1. And it's the same for arc cosine. And then the domain for arc tangent is all real numbers. Because remember, the range for tangent is all real numbers. So, since the range for tangent is all real numbers, the domain for arc tan is all real numbers. Now let's look at the ranges. So for sine, arc sine, the range is going to be negative pi over 2 to pi over 2, with the ends included. For tangent, it's negative pi over 2 to pi over 2. But this time the boundaries are not included because you got asymptotes there. And for cosine, it's 0 to pi. And it's important for you to know these ranges so that you get these problems up here correct. Alright, so let's go on to the next page. Now, in the next set of problems, we are solving over the interval from 0 to 2 pi. And I'm going to go ahead and bring up a separate piece of paper on which to do these problems, because they are going to take a little bit, and I don't want to be smushing them into this one piece of paper here, this little space. So for the first problem, we have cosine 2 theta is equal to sine squared theta. So the first thing that I'm noticing here is that these two angles are not the same. So I'm going to need to use a cosine identity in order to make these angles the same. So I have 3 choices. I have cosine squared theta minus sine squared theta. I have 2 cosine squared theta minus 1, and 1 minus 2 sine squared theta. And I'm thinking that the one that fits best in this equation is the 1 minus 2 sine squared theta, to match the sine squared theta on the other side of the equal sign. So I'm going to go ahead and substitute in 1 minus 2 sine squared theta for the cosine 2 theta. I'm going to add my 2 sine squared theta to each side and get 1 is equal to 3 sine squared theta. I'm going to divide by 3 and get sine squared theta is equal to 1/3. Then I'm going to take the square root of each side and get sine theta is equal to plus or minus root 3 over 3. Now, unfortunately, this is not a nice, beautiful, special angle on the unit circle. So we're going to have to go to the calculator to find our answers from here. So what we're going to do is go ahead and set up the window from 0 to 2 pi. And we're going to go by pi over 2's. So that's our quadrants. And then we're going to make sure that our calculator is in radian mode. And then we can go put this in. So we're going to go ahead and put in sine theta, or sine x, and then here we're going to put in our positive root 3 divided by 3. And then we're going to go ahead and graph that. Okay, so now I can use second calc. I can use number 5, our intersect, and I'm just going to go all the way back to the first one. I'm just going to go in order here. So our first answer is 0.615. Our second answer is going to take a second or two, is 2.53. And our third answer, now for the third answer, we got to go back to our graph. We've got to go back into y equals. And we've got to change that root 3 over 3 to a negative root 3 over 3 to get the next two solutions. And then into our calculate menu, number 5. So we can just continue on here. And our next solution is 3.76. And then for our last one, $5.67. And then to check this, what we can do is go back to y equals, clear all that out, and put in our cosine 2x our sine squared x, And then let's go ahead and just put in our positive root 3 over 3. Oops. And graph all of that and see what we come up with. If we come up with the same set of solutions here. So there's our cosine 2x. Sine squared x. Alright, so what we're looking for is to make sure that we've got all the same intersection points here, and maybe I did this in too jumbled a way. So let's go back in and get rid of some of this stuff. So let's bring the cosine 2x up here, and let's bring the sine squared x out here, and then get rid of this stuff and just graph it. Okay, and here comes our sine squared x, and we can see those intersection points, so we can just make sure that our answers make sense by going to any one of these. And there's our 2.53. So I'm pretty confident that we've got the right set of solutions here. All right. So let's go on to problem B. So problem B is 2 sine squared x plus 3 cosine x minus 3 equals 0. And so what I'm noticing is here, you know what, I'm going to focus this one more time because this looks a little bit bleary to me. Maybe that's a little bit better. Alright, so what I'm noticing here is I've got sine squared here and I got cosine there. And that's not a good thing. I need them all to be cosines, or all sines. Now, since I can't change the cosine at all, what I can do is I can change that sine squared by using a Pythagorean substitution. So what's going to happen is I'm going to circle this, I'm going to remove the sine squared x, and replace that with 1 minus cosine squared x, plus 3 cosine x, minus 3 equals 0. So I have my 2 minus 2 cosine squared x, plus 3 cosine x, minus 3 equals 0. So I'm going to combine my like terms and get a minus 1 down there. And then, since I don't like having a leading coefficient that's negative, I'm going to multiply the entire equation through by negative 1. And that's going to make it a whole lot easier for me to factor this. Now, I'm going to get a 2 cosine x here and a cosine x here. And this one's not that hard to factor because this is a positive one, which means my signs have to be the same. They're both negative. So I'm going to get cosine x equals 1/2, cosine x equals 1. So the solution set for that is going to be pi over 3 and 5 pi over 3. And cosine is 1 at 0. There you go. Oh, and also at 2 pi, because I think 2 pi is included in the interval. And it is. So let me go ahead and put that in. Alright. Let's go to problem D. Now, problem D is cosine x plus pi over 2 minus cosine x minus pi over 2 is equal to 1. Now, with this problem here, I'm going to need to use the cosine sum and difference identities in order to expand these out. So it's going to be cosine x, cosine pi over 2, minus sine x, sine pi over 2. And then, since I'm subtracting, and I'm going to be turning this into two terms, I need to put parentheses. Cosine x, cosine pi over 2, plus sine x, sine pi over 2 equals 1. Distribute the negative. So cosine, cosine, minus sine, sine, minus cosine, cosine. Distribute the negative, minus sine, sine. Now, you have a positive cosine x cosine pi over 2 here, and a negative cosine x cosine pi over 2 here. These are going to cancel out. They're going to add up to 0. They're gone. Now what you have left is 2 negative sine x's sine pi over 2's. So we're going to put negative 2 sine x sine pi over 2 is equal to 1. Now I know that the sine of pi over 2 is equal to 1, so I'm going to take that, I'm going to evaluate it and put it right here. So negative 2 times 1 times the sine of x is equal to 1. This is just negative 2, so I'm going to divide each side by negative 2, and I'll have sine x is equal to negative 1/2, and now I'm ready to evaluate that. So sine is negative 1/2 on the pi over 6 family, so it's going to be 7 pi over 6 and 11 pi over 6. All right. So now let's look at problem E. So problem E is sine squared x is equal to 3 cosine squared x. Now, there's a couple of ways that we can do this problem. We could go ahead and convert one of those using a Pythagorean identity. Or, I'm looking at this, and we could actually just change this into tangent by dividing each side by cosine squared x. And I think that it's going to turn out the same way no matter what we do. This might be just a little bit easier and a little bit faster. So tan squared x equals 3. Take the square root of each side. Tan x equals plus or minus root 3. Well, that would be the pi over 3 family, all of it. 2 pi over 3, 4 pi over 3, 5 pi over 3. And there we go. Now, you could also have changed one of these using a Pythagorean substitution. I'm sure that doing it that way would yield the same answer. Problem F is another tangent squared problem. So tan squared x is equal to 1. Just take the square root of each side and get tan x equals plus or minus 1. And again, we're going to get all 4 of our pi over 4 family answers. So 3, 5, and 7. And there you go. So we did E and F pretty much the same way. E was a little bit more complicated, but turns out that we used the same technique at the end. All right. So let's go ahead and look at problem G. So G says that we have cosine x is equal to cosine 2x. Now, let's bring back those choices that we have for substitution in for 2x. Because remember, those angles are not the same, and they need to be in order for us to solve. So I have the cosine squared x minus sine squared x option, the 2 cosine squared x minus 1 option, which is the one that I think fits best with what I have on the other side of the equation. So that's the one I'm going to use. So I am going to substitute 2 cosine squared x minus 1 in for the cosine 2x. Then I'm going to subtract cosine x from each side, setting the equation equal to 0. So 2 cosine squared x minus cosine x minus 1 equals 0. So now I'll factor the equation. I have a 2 cosine x here, a cosine x here, a 1 here, and a 1 here. Now I want this one to be negative so that when I multiply the 2 cosine x by 1, I get a negative 2, a positive 1, and that'll add up to that negative 1 in the middle. Then I can set each factor equal to 0 and isolate, so I'll get cosine x equals negative 1/2, cosine x equals 1. So cosine is negative 1/2, at 2 pi over 3 and 4 pi over 3, and it's 1 at 0 and 2 pi. All right. Looking at problem H is going to take a bit of room. You have cosine of 3x is equal to 1/2. Now this is definitely a candidate for a u substitution. So what we're going to do is let u equal 3x. So we'll have cosine u is equal to 1/2. Well, that's not so bad. So that's going to be pi over 3 and 5 pi over 3. But remember, when you're doing these, you want to be solving it for all real numbers. So we're going to go ahead and add that 2 pi n. Well, now that u is all nice and isolated, we're going to substitute 3x back in. So we have 3x is equal to pi over 3 plus 2 pi n, and 3x is equal to 5 pi over 3 plus 2 pi n. Now we have to divide all the equations by 3. And it's the same thing as multiplying by 1/3. So what we're going to get is x is equal to pi over 9 plus 2 pi n over 3, and then x equals 5 pi over 9 plus 2 pi n over 3. Now before I can go any farther, I need for my denominators to be the same. I need a common denominator. So I'm just going to multiply this term right here by 3 over 3. And what I'm going to get is x equals pi over 9 plus 6 pi n over 9, and x equals 5 pi over 9 plus 6 pi n over 9. And now I'm ready to start substituting integers in for n right here. Now since I'm only going from 0 to 2 pi, I'm going to go ahead and start by substituting in 0. And when I do that, I'm going to get pi over 9 plus 0 pi over 9, which gives me pi over 9, and that's my first solution. Then I'm going to substitute in a 1 right here. So I'm going to get pi over 9 plus 6 pi over 9. And I'm going to get 7 pi over 9. Now, if I try to substitute a 2 here, actually that's still going to work. So I can do that. Pi over 9 plus 12 pi over 9 is going to give me 13 pi over 9. And that's 3 of my 6 solutions. So now I'm going to come over here to my other equation, and I'm going to do exactly the same thing. I'm going to take my 5 pi over 9. I'm going to substitute a 0 right here and get 0 pi over 9. And that gives me 5 pi over 9. Then I'm going to substitute in a 1 for that n. And I'm going to get 6 pi over 9. And that will give me 11 pi over 9. And then my last substitution, I'm going to substitute in a 2 right here and get 5 pi over 9 plus 12 pi over 9 gives me 17 pi over 9. And I can see I'm right up on the edge of 2 pi right there. So I cannot go any further. These are my 6 solutions here, 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 and here. And I knew I should get 6 solutions because I get 2 solutions on an interval of 0 to 2 pi with just a plain cosine x. But now I'm going to have 3 cycles of cosine on that interval. So I'm going to get 3 times 2, or 6 solutions. All right, let's move on. Let's move on to I. So in problem I, we have sine squared x minus cosine squared x minus cosine x minus 1 equals 0. Now, I can see that all of these terms, well, 2 of these terms are written in terms of cosine, and 1 of them is sine. So I'm going to go ahead and I'm going to substitute in 1 minus cosine squared x here, so that everything is in terms of cosine. And when I do that, the 1's are going to cancel out. I'm going to have negative 2 cosine squared x minus cosine x is equal to 0. Now look at how both of these terms have a cosine x. So I'm going to factor it out. And I'm going to be left with negative 2 cosine x minus 1 equals 0. Set each of the factors equal to 0. And I'm going to get cosine x is equal to negative 1/2. So cosine has its zeros on the half pies. Pi over 2, 3 pi over 2. And cosine is negative 1/2 at 2 pi over 3 and 5 pi over 3. Now guys, honestly, in this unit, we have done cosine equals 1/2 and cosine x equals negative 1/2 probably about 20 times. Nobody should be getting that wrong. All right, next problem, J. We have 2 cosine squared x plus 3 cosine x equals negative 1. Now with this one, everything is in terms of cosine, so all I need to do here is set the equation equal to 0 and factor. So cosine squared x plus 3 cosine x plus 1 equals 0. And then we'll go ahead and factor. So we have a 2 cosine x here, a cosine x here, and then I have 1s because 1 times 1 is 1, and everything is positive, so I just get pluses. So I get cosine x equals negative 1/2 again, and cosine x equals negative 1. So on the interval from 0 to 2 pi, I've got 2 pi over 3, 4 pi over 3, and pi. And there we go. All right, number 17. So we are given this equation, 3 sine squared x is equal to negative 4 cosine x plus 4. And the first thing that we're supposed to do is write it in this format, a cosine squared x plus b cosine x plus c. And all of those a, b, and c's are supposed to be integers. All right, so let's take a look at this. So it's all supposed to be in terms of cosine, and I've got a sine squared here. So I know that I need to use a Pythagorean substitution to get rid of that sine squared x. So I'm going to put in my 3 times 1 minus cosine squared x equals negative 4 cosine x plus 4. So I'm going to have 3 minus 3 cosine squared x is equal to negative 4 cosine x plus 4. Now I'm going to go back and look at the instructions so that I know exactly what the format for this equation is supposed to look like. It's supposed to look like f of x equals, and I need to set it up in that order. Cosine squared first, then cosine, and then my constant. So I'm just going to add my 3 cosine squared x and subtract my 3 from the other side of the equation. So I'm going to get f of x is equal to 3 cosine squared x minus 4 cosine x plus 1. And that's the answer to the first one. Then the next thing tells me I'm supposed to factorize f of x. So let's see what's going to happen here. Well, there's not a whole lot of ways that we can get this done. So 3 can only be split one way. 1 can only be split one way. And since that 1 is positive and the middle term is negative, they both have to be negatives. That plus tells me that these have to be the same sign. The minus tells me they both have to be negative. Then it's going to ask me to solve f of x equals 0 for 0 to 360 degrees. I'm going to put this up here. 0 to 360 degrees. So that means that my answers have to be in degrees, not radians. So I've got to put on my degree thinking cap. So I'm going to have cosine x equals 1/3 and cosine x equals 1. So cosine x is 1 at 0 degrees and also at 360 degrees. Now, I'm not going to panic with that 1/3 because I know I can go to my calculator and I can make sure that my calculator is in degree mode. And then all I have to do is just do arc cosine of 1/3 to get my answer that's in quadrant 1. And so that is going to be 70.5 degrees. Now, in order to get the other solution, remember cosine is also positive in quadrant 4. So what I'm going to do is draw this so that you can see what we're looking at here. So if we estimate 70.5 to be maybe right about here, from the x-axis to the terminal side here is about 70.5. We also have an angle in the 4th quadrant that's going to satisfy this equation. And it's this one right here. But guess what? Its reference angle is 70.5 degrees. So all I need to do to find this is to subtract my reference angle from 360. And it'll give me 289.5. So 289.5 degrees. And all we did was use the reference angle to find that. Okay. Moving right along to number 18. We are asked to show that, which means that is an informal proof. So you need to show all the steps. Show that f of x is equal to sine x. Well, f of x is sine cubed x plus cosine cubed x times tan x. Well, the only thing I can do right now is multiply these two together. So before I can do that, I have to change my tangent x into sine x over cosine x. And I'm going to notice that the cosine in my denominator is going to cancel with one of the cosines in my numerator. And I'm going to get sine cubed x plus cosine squared x times sine x. And then I'm going to notice that both of these terms have a factor of sine, so I'm going to factor it out. And I'm going to be left with sine squared x plus cosine squared x. And this, guys, is just 1. So this is sine x times 1. So f of x is equal to sine x. Okay. Now, let's also go back and look at where this angle is, where x is defined. X is an angle that is defined between pi over 2 and pi. So the next thing it asks us to do here is to show that. So we need to show all of our steps and explain. Show that f of 2x is equal to negative 3 root 7 over 8. So what we have to do is we have to remember that f of x is equal to sine x. So f of 2x is equal to 2 sine x cosine x. So we've got to put that in there. Then what we're going to do is go ahead and make our coordinate plane. Going to go ahead and draw that in. Our triangle goes in quadrant number 2. Here is our x right here. And I know that cosine is negative 3/4. So to find my missing side here, I have to do negative 3 squared plus y squared equals 16. 9 plus y squared equals 16. So that means that y squared is equal to 7. Y equals square root of 7. So now what I'm going to do is substitute the sine and the cosine into my f of 2x. So f of 2x is equal to 2 times the sine, which is root 7 over 4, times the cosine, which is negative 3 over 4. The 2 and the 4 are going to cancel here, and I'm going to get negative 3 root 7 over 8. And I've just shown all the steps there. Alright, moving on to the next problem. Okay, so it says here that the following graph shows the depth of water y meters at a point P during one day. The time T is given in hours from midnight to noon. A sailor knows that he cannot sail past P when the depth of the water is less than 6 meters. Given the equation of the tides is f of t equals 8 cosine pi over 6t minus 1 plus 10, calculate the values of t between which he cannot sail past. Algebraically, show all work, express answer in interval notation. So, the first thing I have to remember is that the depth of the water is y, or f of t. So the 6 is going to replace the f of t, equals 8 cosine pi over 6 t minus 1 plus 10. Now, I don't know about you, but I don't like that pi over 6 times t minus 1. So I'm going to do a u substitution. Let u equal pi over 6 times t minus 1. Now, we should be getting used to these u substitutions by now. Now we have 6 is equal to 8 cosine u plus 10. And remember, the object of the game here is to isolate that cosine u. So I have to subtract the 10. And when I subtract the 10, I'm going to get negative 4 is equal to 8 cosine u. Divide by 8 and get negative 1/2 is equal to cosine u. Well, I know that the cosine is negative 1/2 at 2 pi over 3 and at 4 pi over 3. That's what u is equal to. But now I'm going to go ahead and substitute my pi over 6 t minus 1 back into this equation. And I'm going to get pi over 6 t minus 1 is equal to 2 pi over 3. So I'm going to multiply both sides by 6 over pi first. I'm not going to distribute that 6 over pi through. And I'm going to get t minus 1 equals 4. So I'm going to add the 1 and get t equals 5 hours. So if we go and look at the graph and we see that 5 hours, it looks really close to what we're doing. So I think we're on the right track here. And then we're going to do the same thing over here. I'm going to substitute in my pi over 6 times t minus 1 for the u. Set that equal to 4 pi over 3. Multiply both sides by 6 over pi. The pi's cancel out. And I'm going to get t minus 1 equals 8. T equals 9. So the interval over which that ship cannot sail is from 5 o'clock in the morning till 9 o'clock in the morning. That's interval notation, and there we go. Because that's when the water is less than 6 meters deep. And it is parentheses and not brackets because it's a strictly less than. Alright, let's look at the last 2 equations on the back. Then we can finish up this long video. Alright, so this equation right here, we're solving on the interval from negative 2 pi to 2 pi. And what we have here is 2 sine x equals cosine x. So seeing that the angles are different tells me that I have to use a sine double angle identity to replace this sine 2x. So I'm going to use 2 sine x cosine x equals cosine x. Now I know that it's very tempting to divide that cosine away. Don't do it. You're going to lose solutions. Subtract instead. So 2 sine x cosine x minus cosine x equals 0. We'll factor out that cosine x and be left with 2 sine x minus 1 equals 0. So cosine x equals 0 and sine x is equal to 1/2. So on an interval from 0 to 2 pi, cosine is 0 at 0. And also at 2 pi, right? And then sine x is 1/2 at pi over 6 and 5 pi over 6. So to get the other answers, I have to subtract 2 pi from each one of my solutions that I have here on 0 to 2 pi. So I'm going to get negative 2 pi, and then I'm going to subtract 2 pi from this one. Now 2 pi is 12 pi over 6, so I'm going to get negative 11 pi over 6. I also have to subtract 12 pi over 6 from this one. So I'm going to get negative 7 pi over 6. Then I'm going to get 0. I'm going to get pi over 6. I'm going to get 5 pi over 6. And I am going to get 2 pi. And I'm not sure if you can see all those answers, so let me scoot this over just a little bit. And then the last problem is definitely a u substitution again. Now this time we're only solving over 0 to 2 pi. So I'm only going to have 4 answers this time. I'm not going to have all those answers that I had in the last problem. So I'm going to let u equal to theta. So cosine u is equal to root 3 over 2, which would make u equal to pi over 6, and u equal to 11 pi over 6. Now remember, I need to have that 2 pi n, because I'm solving over all real numbers at first. Now I can go ahead and substitute my 2 theta back in. And I'm going to get 2 theta is equal to 11 pi over 6 plus 2 pi n. And divide everything by 2 and get theta is equal to pi over 12 plus pi n. And theta is equal to 11 pi over 12 plus pi n. But remember, I have to have, oops, sorry about that, guys. But remember, I have to have a common denominator here. So I'm just going to make that 12 pi n over 12 and 12 pi n over 12 here as well. Now I can start substituting integers in, and since my interval starts at 0, my first n is going to be 0. So I'm going to get pi over 12 plus 0 pi over 12, and get pi over 12 as my first solution. Then I'm going to substitute in a 1 and get pi over 12 plus 12 pi over 12, and get 13 pi over 12. Then in my next one, I'm going to have 11 pi over 12 plus 0 pi over 12, which will give me 11 pi over 12. And then my last solution, 11 pi over 12, I'm going to substitute a 1 in here as well, 12 pi over 12, which will give me 23 pi over 12, and that's all 4 of my solutions. Let you take a look at that. Okay, guys, this very, very long problem, or this very, very long video is now over. Study hard. See you next week.